Welcome to Module 2. Welcome to Module 2 and Objective 2. So this is the follow-up from after we haven't looked at vectors and raster data. And so this is just expanding on that, and it's more specific to file types. So we're going to look a little bit at file types. This is really not like the most exciting lecture. File types can be really boring. So I'll try my best to liven it up for you guys as much as I can. So first of all, when we're dealing with vector data, it's important to know that really every data format is not created equally. So we need to know what the different data types are, and we need to know what format we want to use, because that's really critical to how you're going to distribute data to your clients. It's important on how you're going to analyze the data and making sure that you don't lose any data as well. So there are three main types of vector data, which we've talked about before: coverages, shapefiles, and the geodatabases. So we're going to look a little bit at all three of them and the different file types that come with it. So if we talk about a coverage, this is the very first the very first kind of file that we would have with the vector model. So it's an old version. You don't really see it anymore, but it has spatial and non-spatial data, but it has multiple classes and feature classes. So you can see here that we might have like a data set, which is the coverage, and then we'll have different types of feature classes. There, we can also have topological features. There's many files that are associated with this. And then we have different tables off to the side that have every attribute that we can use within these. So it is an old file data format, so you just have to be aware when you come across it. But really, most of the time, we're going to be using a shapefile. So the shapefiles are used to store all of the information that we need for our features. So we have the geometry, and it has to be the same geometry. So for example, if it's a point, it's going to be all the data for that feature that is a point. You can't mix points and lines in the same shapefile. It has to be separate. And if we are looking in ArcGIS, we're going to see that it has a .shp extension. So, but if we look on Windows, we're going to see a whole bunch of different data files. So if we look at this little example here, in ArcGIS, we're going to see just a .shp. But over here, we can see in Windows Explorer, we're going to have a whole list of different kinds of files. So the main files that you need in order to have a shapefile is the .shp, and that has all of the feature geometry. So it says, okay, it's a point file, or it's a polygon file, and this is what the shapes look like. Then, and kind of where it's located, and all that information gets put in the shapefile. Then we have an SHX file, and that is an index for the geometry. So we were talking about before about having a feature ID. This is how it's indexed. So that particular file looks at that. Then there's a DBF file, and this is the attribute information. So the SHP is the geometry and location. The DBF is the attribute, and the SHX is the index of all the different features that you have in that file. Then there's a whole list of other files. So we have the SBN and the SBX, and that has spatial index of the features. So again, it's an optional file, but if you do happen to have it, it's just telling you where spatially and in what order the features are in. There's also an FBN and an FBX file. And again, that looks at that spatial index, so kind of what order are each features at. And it's just a read-only. So it has the same information as the SBN and SBX, but they changed it to a read-only. And then there's AIN and AIH, and this is the attribute index of the different fields. So if we have something highlighted, and that's what it means by active, if I highlight it, it produces those, and then it'll have those there as we move through the data. There's also an ATX file, and that is for created in ArcCatalog. So again, it's more attribute data and just storing it in a different format. There's the IXS, which is geocoding for reading and writing the shape file. And when I say geocoding, that means like an address to a certain location. And this is an index, so again, kind of ordered it in. And then MXS is the same idea, except it's a different format. Then there's the PRJ, which is actually relatively important if you're dealing with real world data. So it is optional, you don't necessarily need it, but it has the coordinate system information. So then it knows what kind of distortions are going to be happening, what the coordinates are supposed to look like, and all that. There's also an XML file, which is the metadata, and so that contains all the information about the shapefile that you can set as the user. And finally, there's the CPG, which is what we call a code you can use to specify a code page to what character set can be used. So a little bit more on the programming side there. So if you do get into that one, that'd be more advanced. Then we also have the geodatabases. And so there's three types of geodatabases. There's the personal, there's file, and there's enterprise. Now, what's missing in this is mobile geodatabase, which is set up on the ArcGIS Online system. And so with ArcGIS Pro, you see more of that. You'll definitely see file geodatabase, but to get a personal or an enterprise, those ones are a little bit more of a workaround. And so because they're just not used unless you're using the enterprise, then that one's a little bit more used more with larger corporations. The personal geodatabase is a little bit of an older format again, but it's stored in an Access database format, and it's really small. Like it's only 2 gigabytes that it's allowed, and it's only for one single user or a small work group. So and you can only use it on Windows, so you couldn't use it on an Apple. So it was really, really limited in what it could do, but it used very little power to be able to operate. So it was beneficial in that way. But like I said before, it's not supported in ArcGIS Pro, so you don't see that. Then the file geodatabase, this one is the main one that you're going to be using in ArcGIS Pro. In this course anyways. So it's stored in folders, and you can use it for a single user, or you can use it for work groups, and you can use as many people can have access to it. There's no size limit, so you can get really big projects with it, and it can be used on any platform. So it is much more flexible than the personal geodatabase. That's why they've kind of phased it out. The personal geodatabase has been phased out and moved towards the file geodatabase. And last is the enterprise geodatabase. So this is the other geodatabase that you're going to see as on a desktop. And you need a special license for this one in order to have the enterprise geodatabase. So it is stored in a commercial format, and it's designed for many users to be using it at the same time. And so you can have many people editing and have different versions and so forth, which is really good when you're dealing with a lot of work people and a lot of data. It does require a special license and something called Spatial Data Engine to be able to keep the data moving. So large corporations will use this, and it is available in ArcGIS Pro, but it's not the one that you're going to be using. You'll be using File. And you will also have the opportunity to use mobile, which is not listed here, but the mobile geodatabase is the other one that is supported in a regular license for ArcGIS Pro. So some of the advantages of using a geodatabase, like why would we use a geodatabase? Well, first of all, we can use all kinds of data types and put it all together into one. It uses rules and relationships. You can have large volumes of geographic data that's stored in an easy to read format, and that's what's really important there. Then it's scalable, so I can make it larger, smaller. It also has the ability to take a lot of data in terms of size, so you can have many, many terabytes. And it allows you to use many advanced GIS data models. You can use different analysis. You can use look at different behaviors of data. You can also maintain spatial data integrity. And so again, I can have it all in one coordinate system, and therefore it all matches correctly. And then it also supports multiple users, so it's not just you working on it, but your entire organization. More advantages is that I can now take because I'm dealing with so many different kinds of data, I can come up with either simple or very complex data structures to be able to access my information. And we can have really long transactions and long GIS workflows working within that geodatabase. It can also have different uses and applications. So I have all the data in one spot. So now I can just keep going back to that data and keep using it for different reasons. And which is really powerful because you don't want to, it's very expensive to capture data and go out and collect it. So if you can use the same data over and over again, then that saves a lot of money in the long run. It is also proven to work through real case studies. So, again, it's used over and over again. So please use it. And also everything, if you are using the enterprise geodatabase, everything, all the elements are in a geodatabase. It also has schemas and rule bases with the spatial and attribute data. So if you get more into the nitty gritty of this, then you'll learn more about schemas and rule bases. So that's it for the vector model. So now we're going to talk a little bit about the raster model. So the raster has many different kinds of software that you can use for processing. So here's just a list of a few of them. Envy is used in GIS 451. I don't know if it still is, though it might be changing over to ArcGIS. ArcGIS also has a really powerful image processing software, which is really good. And so that would be really beneficial to get to know that one, right, in your remote sensing. And then there's these other ones that are listed here. There's so many different kinds of software for raster processing and a lot of open source packages as well, which are not quite as industry standard as ER Mapper or Envy or PCI or ERDIS. So those are kind of the main ones that you're going to see when you're working in industry. There are also different formats that we can find. So you'll find an Esri grid, which is their typical raster format. There's Mr. SID, there's ERDIS image, which is .img. There's .rst, there's .jpeg, there's .tiff. There's also .dat if you use Envy for that. And so they have their own format for rasters, and that's a .dat. So ArcGIS actually supports many of these different raster files, and that's why I'm talking about that and mentioning all these different softwares, because if you go out and you use those softwares, you can still take and export it into a format that ArcGIS can use. So if you go to the supported raster formats, right here, you're going to see, I'm going to just move that over a little bit. So you'll find on the web page, when you follow that link, it's going to give you all these different kinds of data. So everything from microwave and different band interleaved, or like the different versions, BIL, BIP, BSQ, bathymetric data, and on and on and on. So you can see that it just keeps going on this page. So there's tons of them. So if you're looking to look at you're wondering what raster format you can bring in, you can take a look there. So this is kind of a funny addition to this this whole PowerPoint, because it doesn't really necessarily relate to the file formats. It's kind of like thrown in there at the end. But so one of the key things with the raster model, and I'm just going to tie this into the previous lecture, is that you can have a thematic raster model, and it doesn't necessarily have to correspond with like reflectance, which is how much energy has been reflected off of a surface so that you can see it. So such as like a flash or something. So pixel values don't have to be that, if like a photograph. It can be anything that has a pixel, like a certain value, and we just color it based on that value. And that's called either a color table or raster slices. So the pixel values correspond to different classifications or categories. So in our example here, we have land use. So agriculture, bare land. None of these are actually like a photograph, right? So they're what we consider a thematic version or a thematic classification. And these are known as discrete rasters. So a discrete raster has like set boxes, set colors for very particular themes. And so we refer to that as a discrete raster. So in summary, we have the coverages, which is a one type of vector data format, and we rarely ever use that, but you might come across it while you're out working in industry. There's also shape files, and they have multiple data files. And so you're going to see different extensions, and some of them are optional. Then there's three main types of geodatabases. So there's personal, which you don't use in ArcGIS Pro. There's file, enterprise. But the main one, the ones that you're going to be using is file and mobile, which we didn't talk about here. And there's also many raster formats that ArcGIS can handle, which is really beneficial so you can process them in another software and bring them into ArcGIS. So you want to finish up those readings in chapter 5 and 6 and complete assignment 1. And that is everything. So that is objective 2 for module 2.